in this part, we're gonna talk about the architecture of the system. So, what basically our project do is our project actually tracks the people movement, how the people when the people enters in the store, uh, which section they actually explore in the store, when they enter and when they exit, how much for how much duration they actually stays in the store. So we need to track all these things and we need to send this data, and on this data we then do further analysis. So our main task is to dynamically design a robust scalable system or a pipeline which actually track this data and store it, right, persistently. So how are we going to design it? So what I do for actually tracking the objects of the humans, I uses is CV pipeline. Now how I build the CV pipeline? So the complete magic starts from here. The system takes a standard CCTV video feed and uses computer vision to understand what's happening. First, it uses YOLO V8, which is a powerful AI model to detect all the people in a frame of a video. Next, see, this actually creates one problem. What's the problem is? The problem is, let's say the same person can go out of the frame and come again in the frame. So it will actually recalculate the person as new person, which is a wrong thing. That's why in order to resolve this problem, I use byte track, right? That actually follows each person from frame to frame and assign them a unique ID to avoid that same person moving around issue, right? And finally, when a person tracks means whenever a person identified as a when a person get a unique ID, so we actually generates the event, simple meaningful event like entry or an exit, right? Whenever the person enters in the store or not, or exits. So why actually uses these technologies? See, we choose YOLO because it's extremely fast and accurate, making it perfect for real-time video analysis without expensive hardware. And I use ByteTrack because it's very effective at tracking, which is very crucial for accurately calculating how long people stay and where they go and resolving that same person issue. Now see all these person movements, like person dynamically moves, this will actually generate the new events. And if I directly store these events in my database, so this will actually create a lot of issue because it will actually overload the database for every particular minus second. Let's say there are multiple cameras, we have multiple stores, every stores have multiple camera, so multiple camera will generate an event, like, and stored in the database, which will actually cause a lot of database overloading. Also database throughput is way less, which will actually and database operation per seconds are also too less. So this will actually overload the database and make database down. So in order to resolve this, we actually use Redis. Now why I use Redis, why not Kafka? Because Kafka can be an overkill for this particular project. So I use Redis because Redis is fast as it's built upon RAM. So the operations are a little bit faster as compared to other. So right, so I use Redis for this event streaming. Right, so every event entry on exit generated by the CV pipeline is immediately sent to Redis stream. Think of Redis stream as a reliable conveyor belt. It takes all the event from the pipeline and line them up, ready for the next stage. Now, why I use Redis stream? It's persistent, right? Let's say if the system crash, the events are not gonna lost. They are safely stored and will be processed when the system came back online. And one of the most important thing for scalability, which is decoupling, it separates the video processing part from the data analysis part. The CV pipeline's only job is to produce events. It doesn't need to worry about what happened to them next. This makes the system much more resilient. Now we talk about the background processes. See, this is actually the brain of the system. What it does, it actually a dedicated worker constantly watches this Redis, right, for the new event. When a new event appears, this worker actually pick up those heavy events, right, And what they do, whenever they pick up the event, it actually process the event data. For example, person entered at 10:05, person entered in this particular section of store, right? And it actually calculates the total it's actually calculates the total visit of a person in the store, right? It handles idempotency, which makes sure that if the same event is accidentally sent twice, it only get processed once, right? So all these things are handled by the background worker, right? And now comes data storage. So I prefer using a means SQL data server. Why? Because see, worker saves the process information into a database, and which is our source of truth, and this system or this database actually stores our system long-term memory, and these data is actually organized in tables like events, sessions, and metrics, right? So in order to get a relational relation between all these tables, I prefer using SQL database, right, which is preferred for these kind of structured data. Also, it also helps us to perform analytic query like finding the average visit during per hour, counting total number of entries, right? So it helps us to do analytical queries, right? Like also, NoSQL database can be a great choice for unstructured data where we don't have a clear relationship. However, in our particular project, we actually need to perform queries, as I earlier mentioned, on tables like event, sessions, and metrics. That's why I prefer Postgres SQL over a NoSQL database. Right. Now comes up our main backend part. Like all this thing is designed in Fast API. So like what it does, it actually this is actually how the user interact with the data. It's like the main work, the main backend is designed in Fast API. Fast API server, it actually provides a simple API endpoints like metrics, heat maps, and etc. etc. Whenever user requests data from analytics dashboard, the API queries this database and gets the relevant information back. Why Fast API? See, one of the important thing is we actually uses YOLO and this ByteTrack. So these are actually been in Python. So in order to make the environment similar, I use this Fast API. Why Fast API? Only because Fast API is in fastest Python web framework available. Also, it comes with a pre-built Swagger that actually help us to generate, endpoint summaries and all. And combining all these components, we get a clean and efficient and scalable system that actually been designed to solve this real life problem, right, which is given to us by Purple Hackathon. Thank you.